Today we are doing Math 6, Mission 7, Lesson 8, Writing and Graphing Inequalities. So we're going to do some graphing, but it's not going to look exactly like you might be used to. All right, here's a picture of Mr. Sawicki. Let's go with that. Name a number in feet that is clearly too high for his height. Well, there's a regular chair, there he is. So I'm going to say 100 feet is way too tall for Mr. Sawicki. Name a number in feet that is clearly too low for his height. Well, unless this chair is really, really tiny, I would say 3 feet is definitely too low for his height. Make an estimate of his height. Well, I know that most men are about 6 feet. So I'm going to say he's probably 6 feet. Okay. And if that's the case, then halfway would be 3 feet, and that would make the chair probably 2.5 feet. So yeah, I would say that's probably close. Here's a picture of Mr. Sawicki standing next to a student. If Mr. Sawicki's actual height is 5 feet 10, so from here to here, that's 5 feet 10 inches. What can you say about the height of the student in this picture? Now, we're not going to be able to say exactly how tall the student is, but we can give an estimate using inequalities. So I would say that the student is shorter than 5 feet 10 inches. I don't know exactly how tall she is, but I can definitely say that she is shorter, right? Shorter than Mr. Sawicki, and Mr. Sawicki is 5 feet 10 inches. So she is less than 5 feet 10 inches, or shorter. So if we're going to make an inequality, we would say Mr. S is greater than the student, whatever the student's name is, in height, right? All right, let's keep going. You'll get a set of paper slips with 4 stories and questions involving the number 9. Match each question to 3 representations of the solution, a description or a list, a number line, or an inequality statement. So there will be a story. Oh, man. There will be a story, and in the story, you will have 3 things that you're going to have to find. So you're going to have a story, and then you're going to have a description or a list. You are going to have a number line, and you are going to have an inequality to match to this story. So you're matching 3 things to this story. All right, compare your matching decisions with another group. So if there are disagreements, discuss. Okay, so here we go. One of the stories is, ooh, excuse me, I have to sneeze. Oh. Okay. A fishing boat can hold fewer than 9 people. How many people, X, can it hold? So I'm going to slide. Oop, why isn't it sliding for me? And I'm going to do that one. Okay, so here we go. A fishing boat can hold fewer than 9 people. How many people can it hold? So you're looking here, and you are trying to find its matching stuff, right? So what we can say, so you can look through that. I'm going to scroll one more time. You can pause it and look. Okay, so now we're going back. Well, let's open that back up. I don't know where that went. All right. Here we go. So a fishing boat can hold fewer than 9 people. So that's going to be less than 9. Okay? So we are looking for something, a description or a list that's less than 9. Well, I know of one of those lists. It's going to look something like this. 0, 1. Oh, love when it jumps on me. So it's going to look something like this. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's going to look like that. Okay. Now, the reason that I'm going 0 through 8 is because it's fewer than 9. Well, 0 through 8 is fewer than 9. And these are people, right? They're not things. They're not ounces of water, whatever. So I have to have whole people. I can't have half of a person. Okay? So what does that number line look like? Well, it's going to look like you can have 8, you can have 7, 6, 5, right? 4, 3, 2, 1, or 0 people. So that's what that number line is going to look like. Okay? You can't have more than 8 because it says fewer than 9. And you can't have less than 0 because you can only have 0 people. You can't have less than 0 people. All right? So now let's look at the inequality. The inequality here is going to look, that's going to be either less than, equal to, or greater than, right? So our inequality has to say X, the number of people, X can be greater than 0, or, or X can be equal to 0, right? Because we can have 0 people, or we can have more than 0 people. And, right, X has to be less than 9. It cannot be 9 because it says we have fewer than 9. Okay? So X can be greater than 0, equal to 0, and less than 9. Okay? Let's look at B. Lynn needs more than 9 ounces of butter. So with butter, can I have a half an ounce of butter? Can I have a fourth of an ounce of butter? I can. So this doesn't have to be like this one where we have individual dots. To make cookies for her party. How many ounces of butter X would be enough? All right, so what would be the description or the list here? So if we were going to look, we would need any value. If you were going to go back and look at those lists, the descriptions that I showed you, right? One says any value higher than 9. Okay, because we need more than 9 ounces. 9 ounces isn't going to be enough. We need more than 9 ounces. All right, so what does our number line look like? Well, we are going to be on 9, but there is something when we graph inequalities, a filled in dot is going to mean that we include that number. Include the number. An open dot means that we don't include, we exclude the number. So are we including 9? Can I have 9 ounces of butter? No, I need more than 9 ounces of butter. So on 9, I can't have 9 ounces of butter. So I'm going to do an open dot on 9. I need more than 9 ounces of butter. So it's going to look like this. I need more than 9 ounces of butter. In this case, 9.01 ounces of butter will work because that is technically more than 9. Okay, so what would the inequality look like? Well, the inequality would say X, my ounces of butter, has to be greater than 9. It can be any number greater than 9, but it has to be greater than 9. Okay, so let's look at C. A magician will perform her magic tricks only if there are at least 9 people. So could I have 9 people there? Yes. Could I have 12 people there? Yes. Could I have 3 people there? No. Right? For how many people X will she perform her magic tricks? Well, if we're going to look at a description of that, she needs people. So that would say she needs people that are 9, 10 people, 11 people. But again, people are whole people. I can't have a half of a person. I can't have a third of a person. So I need 9 people, 10 people, 11 people, 12 people, on and on and on, right? If she had 100 people, she would definitely perform. If she had 3 people, she wouldn't perform. So what does my number line then look like? Well, it's going to be a closed dot because it includes 9, right? So you're going to have 9, but you can also have 10 people or 11 people or 12 or 13 or 14 or 15, on and on and on, right? So what does that mean? That means that for our inequality, X, the number of people coming, could be greater than 9, or X could be equal to 9. And there's a really cool way to write that. You can combine these two because X could be 9 or it could be greater than 9. And so we could write that as X could be greater than or equal to 9. So we've combined them both together, these two symbols together into this one here. Greater than or equal, that's what that means. Let's look at D. A food scale can measure up to 9 kilograms of weight. Up to 9 kilograms of weight. What weights, X, can the scale measure? All right, let's look. So could it measure 2 kilograms? Yes. How about 3? Yes. So any value it can measure from 0 to 9. That's what we would say. So any value 0 to 9. Okay, so that would be 0, 1, 2, 3, 4, but it also could be 4.765, right? It doesn't have to be a whole number. So what does our number line look like then for that? Well, it includes 0, so we would have to put a dot on 0 because it includes 0, and it includes 9. It can weigh 9 kilograms, all right? Now, it could also take up any number in between those two. So it could be 1, 2, 3, 4, 5. It could also be 4.75, right? It could also be 6.33. So that line drawn like that says it could be any number whatsoever, fraction, decimal, 0 to 9. So what does that inequality look like? Well, that says, X can be greater than 0, or X can be equal to 0. And if we wanted to combine those, we could say X could be greater than or equal to 0. That's this and this together. And, because we can't forget about the other end, X can be less than 9, or X can equal 9. And so we can write that X can be less than or equal to 9. So this and that. Okay. All right, let's look at our next activity. Here's a picture of Miss Taylor and a basketball hoop. Based on the picture, what do you think are reasonable estimates for the maximum and minimum heights of the basketball hoop? Complete the first blank in each sentence with an estimate, and the second blank with taller or shorter. So I estimate the minimum. So I know a basketball hoop is about 10 feet tall, but there are different heights that you can put. My parents have a basketball hoop in their backyard, and I can raise or lower that hoop. So what's the minimum that can be? Well, I estimate the minimum height of the basketball hoop to be, let's say, 8 feet. This means the hoop cannot be taller or shorter. Which one do you think? Means it can't be shorter than 8 feet. So when I'm moving my parents' basketball hoop height, the smallest it can be, the shortest it can be is 8 feet. I can't make it go any lower than that, okay? Now, the next one says, I estimate the maximum height of the basketball hoop to be blank feet. So my husband's playing basketball and he wants to work on his dunks, right? But he's got to work on his jump. So he wants that basketball hoop as high as it can go. So I'm going to say that basketball hoop can go up to 12 feet, right? That means the hoop cannot be taller than 12 feet. Can't be shorter than 8, and it can't be taller than 12. So write 2 inequalities, one to show your estimate for the minimum height of the basketball hoop, and another to show the maximum height. Use an inequality symbol and the variable h to represent the unknown height. Okay, so we could say h has to be greater than 8, right? Because it can't be any shorter than 8. And h has to be smaller than 12, shorter than 12, right? Because we have this hoop. It can go up to 12 and it can go as low as 8, right? But if we were talking about our open and closed dots, I would have to say that it could be 8 as well, and it could be 12 as well. So here I have to say h could also equal 8, and h could also equal 12. So if I were going to write that, I would say h is greater than or equal to 8, and, right? That and is kind of weird. Let me rewrite that. And h is less than or equal to 12. Now, plot each estimate for the minimum and maximum value on the number line. So the minimum, I would say, we'll just say this is 8, right? So there's 8. The minimum is 8. And if we were just talking minimum, then any number above the minimum would work, right? But now let's talk about the maximum. So the maximum is 12, right? And anything lower than 12 would work, right? Because it's below the maximum. So suppose a classmate estimated the value of h to be 19. Well, let's go plot 19. So here is 19. Here is 19. So does this estimate agree with your inequalities for the maximum height? No. It's too high, right? Because if we were to look, is this it? Yeah, so let me redo this just really quick so we have some things to talk about. So here's 8. Oop. And here's 12. Right? So then 19 is here and here. Okay, so for the maximum height, no, it can't. It's off. It's not within our graph, right? It doesn't fall below 12. No. 19 is greater than 12, and 12 is our maximum. does it agree with your inequality for the minimum height? Well, yeah, right? So minimum height, yes, because 19 is greater than 8, and 8 is our minimum. So as long as it's over 8, it's fine. Okay, but when we put our two graphs together, right, if we put our two graphs together, then 19 won't work because it's above our maximum. But when we look at them separately, 19 does work for our minimum. All right, and then this is just checking with a partner, okay? But I want to talk about this. If we were to graph this, I'm just going to graph this really quick down here, right? So we have our number line, and you have 8 down here, and you have 12 up here, then yours is really going to look like this. 8, because it could be 8, it could be 12, but it could be any height in between there. So that's how that would look. A big closed dot on 8, a big closed dot on 12, and any number in between. All right, make sure you review your lesson summary.